This is Mr. Martin, and these are the notes for section 4.1, day 1. So we're going to be looking at angles today. We're going to be looking at radian measure, degree measure, converting between those. So let's get right to it. We've got a loose definition for trigonometry. So from Greek, the loose definition here is that it means measurement of triangles. So, and almost everything that we do in this course is going to have some relation back to triangles. Trigonometry, it's an important mathematics. It's got applications in astronomy, navigation, surveying, sound waves, light rays, planetary orbits, vibrating strings, pendulums, orbits of atomic particles. So if you have any ideas of going into any of these different areas, these are a bunch of areas where you actually will use the math that you're learning in class. So some things that you may remember from geometry, the parts of angles. If I'm starting at this ray over here and I'm rotating to that ray over here, we would mark this angle. We like to use Greek letters to mark the angles. I'll call that theta. And then the ray where we started would be the initial side. And the ray where we end would be the terminal side. Okay, and of course over here we have our vertex. So 3 parts of the angle. And then we show that the rotation of the angle, we use this arc here, this curvy ray here, to show the rotation of the angle. In this case, this would be positive, and we'll talk about more of that in a minute. So let's take a look at this angle over here. Again, I've got my initial side, and I've got my terminal side. And I could mark my rotation over here. We'll call it theta again. Now if you notice, the initial side is on the x-axis. When we put the initial side on the x-axis and its endpoint on the origin, we say that the angle is in standard form. So this angle is in standard form. Right, and almost all the angles that we deal with are going to be in standard form. So in geometry, you mainly dealt with angles that were less than 180 degrees. And that's not going to be the case in here. And we're also going to have negative angles. So positive and negative angles and coterminal angles, this is going to be important for us as well. So if you notice, we've got 2 angles in this first diagram. One of them is going counterclockwise, so that would be the positive direction, and this smaller one, which is somewhere around 40-ish degrees, is going clockwise. That's a negative direction. So again, the second diagram here, we have alpha. This is a positive angle. And if you notice, it is greater than 180 degrees. Okay, and then over here we have beta, which goes in a clockwise direction, and that is a negative angle. So our third diagram here, you notice we have this swirly, red swirly here that goes more than 360 degrees. Okay, so here we have an angle larger than 360 degrees. Alright, and then over here I have alpha, and you notice that both of these angles are positive. And another thing that you notice about both of these examples here is that alpha starts on the positive x-axis and ends at this ray in the third quadrant, and beta also starts at the positive x-axis and ends at this ray in the third quadrant. Okay, and same thing here with alpha and beta. They both start on the positive x-axis. Alpha just goes up about 30 or 35 degrees to the terminal side, but beta goes all the way around and then over to there. So they start and end in the same place. So what we call this is coterminal angles. Coterminal, these are angles with the same initial and terminal sides. So if you think about the hands of a clock and one of the hands is staying on 3, the other hand could just move counterclockwise up to here, or it could rotate all the way around 360 degrees and then keep going past 360 right back to that same spot. So that's coterminal. Just some notational information. In algebra, we like to use x, y, and z as common variables. In trigonometry, we like to use lowercase Greek letters. So we'll use alpha, we'll use beta, we'll use gamma, we'll use theta. Those are about the 4 that we'll use the most. We can use them interchangeably, just like we can variables in algebra. All right, so moving on to radian measure. So hopefully you've made some good discoveries from the activity that we did in class. But the measure of an angle is determined by the amount of rotation from the initial side of an angle to the terminal side. So I like to draw my angles in a circle sometimes. So if I have this ray over here, let's try that again. I've got this ray, and then if I rotate from the initial side to the terminal side, okay, this angle of rotation is the measure of the angle. So the unit of measure that we have, or you have been dealing with for most of your life is the degree. So a full revolution is divided into an arbitrary 360 parts, and each one of those parts is a degree. So with radian measure, that's just another way to measure angles. So to determine the amount of revolution for 1 radian, what you saw in the activity is that we took the length of the radius and we marked it off along the curve. So we marked it off along the curve, and then that amount of rotation there, that theta, that was equal to 1 radian. And then you saw we could mark off, so there's another one, and there's one more. Notice we have just a little bit left to get to 180, so that little bit more. So we've got 1, 2, 3, 3.14, so that's our pi, which we talked about. And then 4, 5, 6, so then this little spot here should be twice as much as that much there. And that's going to be 0.28, and then we get 6.28 radians all the way around, which is equal to 2 pi. Okay, so 1 radian is equal to the measure of the central angle theta that intercepts an arc S equal to the radius of the circle. That should be radius. Okay. All right. So algebraically, this would mean that theta is equal to the length of the arc over the radius, or if we solve this for the arc, we can find the length of the arc if we know the radius and we know the central angle. Now make sure it's important here that the angle is measured in radians. We're going to be switching a lot between units here, and on your calculator you need to make sure that you're always in the correct unit. So get used to switching back and forth between degrees and radians. Alright, so that's where we get the radian. And then keep in mind that full revolution which is equal to 360 degrees is equal to 2 pi radians, and we normally leave off the units. So if the measure of the angle is unitless, you know it's going to be radians and not degrees. So if we wanted to find out, for example, what 1/6 of a revolution, that would be 360 divided by 6, which would be 60 degrees, or 2 pi divided by 6, or pi over 6, 2 pi, pi over 3. Okay, so 60 degrees, pi over 3, and we could figure out in a similar manner, you know, what a fourth of a revolution is, or what a half a revolution is, or what a 1/12 of a revolution is. And we're going to be dealing with a lot of special angles. Alright, so that's the end of this video. Move on to video 2, day 2. That will take you through the examples. If you want to go ahead and figure out or work on those examples on your own, and then go view the videos to see if you got them right, that would be great. And I'll mention this quite often. If you have questions, I would write them down in the margin of your notes so you don't forget, and then when you come to class, make sure that you ask me.